today's graph characteristics for the exponential function are going to be domain, range, intercepts, and zeros. What I have typed underneath here that the ViewSonic board again did not import very well says graph and analyze the key characteristics of simple exponential functions based on mathematically applicable situations. So you're going to see a bunch of mathematically applicable situations today in my notes. There's going to be 2 examples. And I just have, this is a warm-up. I'll go over that in class. I'm not going to put that on the video. Domain. Remember domain from earlier lessons. It's all your possible x values. Your range is all the possible y values. The x-intercept is the point where the function crosses the x-axis. The y-intercept is the point where the function crosses the y-axis. Zeros, that's the x-coordinate of the x-intercept, and asymptotes, the horizontal line that the graph approaches but never crosses. Okay, here's our first scenario. And here is the real world example. I wrote, okay, before I get started on this example, I put real world in blue, in blue, and theory in red. And right here where it's red, that means that they're both the same. So real world and theory are exactly the same there. Sheila is raising rabbits. She has 3 rabbits initially, and the population doubles every 3 months. Now, I wrote us out an equation. Pardon me. We're starting with 3 rabbits, and they are doubling every 3 months. And I wrote it as x over 3 because that way you can put your number of months in. And if you're trying to figure out how many there are in month 1, you can do it easily doing it that way. So anyway, so then I sketched the graph, and if you put it in Desmos, you come up with that. But I sketched it by going, okay, I'm starting with 3, so 0 is 3, and then I'm doubling every 3 months. So month 3, if I started with 3, I should have 6, and then month 6, I should have 12. And so I went ahead and sketched that graph like that. Now, the domain says 0 to infinity because the domain is the number of months. Now, and I put that down. And I put infinity, but really and truly, no scientist is going to observe a rabbit population to infinity months. So usually there would be a time cutoff. So if I said 3 years, well, 3 times 12 would be 36, and so I would end it at 36, but I left it this way for this. Now, here's where the real life scenario started. You had 3 rabbits to begin with, and then I just sketched the rest of the graph this way. And if you put this in Desmos, Desmos is going to give you this whole thing. So I went ahead and sketched it this way, even though there are no such things as negative months. So, but in theory, what I'm doing is I'm looking at this whole graph. So in theory, it's negative infinity to infinity because my x values here, remember this is infinity, infinity, negative infinity, negative infinity. So if I look at this, this is negative infinity, 0, that arrow is. And this arrow up here is infinity, infinity, from earlier lessons where I have discussed how to label those. So the theory domain is from negative infinity to infinity. All right, range. Range, we started with 3 rabbits, and we're going to double every 3 months. So my range goes to infinity, but of course, if you were to give it an endpoint where you stopped observing in 3 years, then you would do 3 times 2 to the 36 over 6, because there'd be 36 months, and you'd find that, and that would be the end. And I wrote my range incorrectly. It's like whenever I teach you, I see my own mistakes. I do better in class than I do on the video because, anyway, it makes sense then when I'm saying it out loud. But, so, if you see this, your y value is going from 0 to infinity because you have that line, that asymptote that you're not crossing. So that's the theory. There are no x-intercepts because this graph is not crossing the x-axis anywhere. The y-intercept is at point 0.03. It's usually your starting point. The zeros, there are none. If it's not crossing the x-axis, then there are no zeros. The asymptote is that line, that horizontal line that the graph never crosses. So y equals 0. Gets closer and closer to that, but it isn't crossing over. All right, now, the real world, looking at the domain and the range. How do I describe the domain in terms of the context? Well, in terms of the context, the domain is the number of months that you're observing the rabbits. So that's going to be greater than or equal to 0 because I'm starting at 0 months and then I'm observing it each month after that as time goes on. The range in terms of the context is that it is greater than or equal to 3. We already wrote that down, and that's the number of rabbits in the context. So in the context of the problem, that's what the range is. Okay, and now this one here, in the past, an endangered species of right whales have been decreasing by 25% each year. There are 600, and the word currently, it was in my notes on, but it was in my notes in my PowerPoint. However, when it imports into this ViewSonic board, it got rid of that word. But anyway, the gist of the problem is up here. So I sketched that one. You can put this one into Desmos as well. We are starting with, and I should put the equation up here, but the equation, we're starting with 600 right whales, and they are decreasing by 25% each year. So there we are. You can do that, or you can write it as 600 times 0.75 to the x. And I've graphed that. We'll spend time graphing that in class. But there it is. So our domain is the number of years. So like I said earlier, you cannot observe for an infinite number of years. So whatever they tell you, if they say, scientists observed the right whale population for 10 years, then you would put 10 here if I had an end on it. All right, and again, this doesn't go past this point because there are only 600 right whales right now. So it's not gonna, if it's decreasing, unless we do something to take care of that endangered species. But this is my theory. So with theory, this graph is going on. So this arrow is negative infinity, and this one is infinity 0. Okay, so the range in the real world goes from 0 to 600 because you can't have negative right whales. You either have a whale or you don't have a whale. So, and this would be integers, whole numbers. You wouldn't have any decimals or fractions here. So it would be kind of have those constraints. But the theory, the graph has arrows on the end. And so in theory, it's going from negative infinity to infinity. Again, there is no x-intercept because it's not going to cross. And then the y-intercept is 0, 600. And that's true in both the real scenario and in the theory scenario. There are no zeros. The asymptote is y equals 0. And so that's the horizontal line that the graph is not going to cross. Now, the domain, let's just talk about the domain in terms of the context. The domain is the number of years that this species is observed, and the range is the number of whales in the context. Thank you.